An elimination reaction is a reaction in which atoms are removed as molecules or compounds. Elimination is generally catalyzed by a metal, an acid, or base. Elimination reactions often compete with substitution reactions. In this reaction, a substrate, typically an alkyl halide, eliminates one equivalent unit of acid to form an alkene. Two possible mechanisms are available for this elimination reaction: E1 and E2 mechanisms. Elimination reaction is a type of reaction that is mainly used to transform saturated compounds, organic compounds which contain single carbon-carbon bonds, to unsaturated compounds, compounds which feature double or triple carbon-carbon bonds. Besides, it is an important method for the preparation of alkenes. An elimination reaction is a type of chemical reaction where several atoms, either in pairs or groups, are removed from a molecule. The removal usually takes place due to the action of acids and bases or the action of metals. It can also happen through the process of heating at high temperatures. Important methods of elimination reaction. Normally, elimination reactions are distinguished by the kind of atoms or groups of atoms that leave the molecule. Due to this, there are two main methods involved in this type of reaction. 1. Dehydrohalogenation. 2. Dehydration. In the dehydration method, there is the elimination of a water molecule mostly from compounds such as alcohol. Sometimes, this method is also called a beta elimination reaction where the leaving group and H are placed at neighboring carbon atoms. On the other hand, in dehydrohalogenation, there is a removal of a hydrogen atom and a halogen atom. Mechanism of elimination reaction. The elimination reaction consists of three fundamental events, and they are: proton removal, formation of CC-pi bond, removal of the leaving group. Depending on the reaction kinetics, elimination reactions can occur mostly by two mechanisms, namely E1 or E2, where E is referred to as elimination and the number represents the molecularity. E1 reaction. In the E1 mechanism, which is also known as unimolecular elimination, there are usually two steps involved: ionization and deprotonation. During ionization, there is a formation of carbocation as an intermediate strategy. In deprotonation, a proton is lost by the carbocation. This happens in the presence of a base, which further leads to the formation of a pi bond in the molecule. In E1, the reaction rate is also proportional to the concentration of the substance to be transformed. It exhibits first-order kinetics. The E1 mechanism shares the features of the SN1 reaction. The initial step is the formation of a carbocation intermediate through the loss of the leaving group. This slow step becomes the rate-determining step for the whole reaction. E2 reaction. In an E2 mechanism, which refers to bimolecular elimination, is basically a one-step mechanism. The E2 mechanism can generally be represented as below. In the below-mentioned representation, B stands for base and X stands for halogen.